Today we are moving into another chapter that is called Alternating Current. So previous to this class, we have discussed about concept of electricity and concept of magnetism separately. But in the chapter electromagnetic induction, we have combined this effect. Actually we have not combined, but according to the scientist Faraday, he tried to see the effect of the electricity and magnetism together. So he said that there is a relation between the concept of magnetism and the concept of electricity. So he combined and he saw the effect. And in the previous chapters, we also know a fact that whenever a charge moves, it will induce magnetic field. And also we know that the converse effect can also be possible, which means that whenever a current carrying conductor is in contact with changing magnetic field, it will induce current. So these are some knowledges that we have earned from the previous chapters. Today we are going to a new chapter, that is alternating current. And we already know about it because it is very familiar for us. Why? Because if you look at our home, we use many equipments. I can say you will use a computer, or I can say you will use a refrigerator, you will use a tape recorder, you will use a television. So all these equipments is worked on AC. AC means it is a kind of energy and it is known as an alternating current. It is called as AC. And there is one more kind of energy you can also see, that is called as a DC. If you look at the batteries, you can see the batteries everywhere, because if you see the wall clock, that will have some battery. If you see your wristwatch, that will also have a cell. And if you see your remote, which you are using for your television to change the channel, that will also have a battery. So everywhere you can see those batteries, and the energy stored in that battery in the form called DC. So that is why you can see two kinds of energy forms. That is called as DC and AC. Then what is the difference and what would be the history of this? How the concept of alternating current have born? So that is we need to understand. So from the previous concept we know that I told you already that even when a current carrying conductor is placed in the presence of extramagnetic field, it will induce a current. Actually, it was a very fundamental knowledge which was given by the Faraday. Because of this knowledge, which revolutionized in the field of energy. In the field of alternating current or in the field of DC. Because it gave many ideas, and because of principle of Faraday, many more equipments have invented. If I say the AC generator, you already learnt in the previous class, and there we will produce alternating current, we will produce energy. So it is an invention on the basis of Faraday's law. So that is why he laid a strong stone for the development of alternating current. Yes. Now let's see some history of this alternating current. And I told you that energy are in two forms. One is a DC form, another one is called as AC form. And the concept of DC means it is actually called as a direct current, and AC is called as an alternating current. And this concept of DC actually formed by scientists called Thomas Alva Edison. We all know about him from our childhood. I think, yeah, from our childhood, because he is inventor of a bulb. So that is why he is very famous. Yeah. So he discovered this direct current, this concept of direct current, and according to this, direct current means the current which flow in a one direction. That is why it is called as a DC, direct current, which means that it will not change its direction as it moves in any circuit, in any wire. So that is why it is called as a direct current, and it was discovered by Thomas Alva Edison. And at the same time, it was actually it was in the late 1880s. In the year 1880s, Thomas Alva Edison was invented the direct current. Was discovered this direct current, and there was a problem with that direct current. What does means? Whenever whenever it is transferred to very long distance, there would be some power loss, or I can say it was not able to him to transfer that DC to very long distances, because there was some power loss in the form of heat. He could not get the exact value of energy that he was sent from one end in the other end. So that was a problem, and it was not possible to carry or transfer this to a very long distance because of this energy loss. And but at the same time, there was another scientist that his name is Nikola Tesla. We heard of him in the chapter Moving Charges and Magnetism, because in the honor of him we named the unit of induction as a Henry, unit of magnetic fields as a Tesla. So that Tesla has gave a solution to this. Our problem is the problem in the Thomas Alva Edison's invention is it was not able to transfer that energy to a very long distance. So for this, Nikola Tesla has given a solution that, and it can be, and he said that it can be corrected by the alternating current. So he has introduced a new term. It is alternating current, and alternating current means where the electron changes its direction periodically. Means the direction of current changes periodically. For a short interval of time, the current will flow in one direction, and at the same time, at that instant of time, the direction of current changes. So such kind of energy transfer is known as alternating current. But at those time, this Edison was not ready to accept the results of this Nikola Tesla, because he has got the because he was earning the money for his discovery, because his discovery was a patented one. So he was not ready to accept this invention, and he was always misleading this. He was giving misinformation to the society that the invention of this alternating current could destroy the human beings, or this could electrocute the nature. But at the same time, there was a bid by the electric company, and where their bid was like this. They wanted to electrify a fair. Fair means jatre. They want to electrify a fair, and so they have arranged a bid. And initially Thomas Alva Edison got the bid, but but he lost after he lost it. Why? Because there was another scientist called George Westinghouse. He applied which for a very low cost, but at that cost the Thomas Edison could not do it because there was a more energy loss in the DC currents. So this is some basics and the history of the this alternating current. So that is why we can transfer energy in two forms. One is called as a direct current in the DC form, another one is called as AC form. So I told you the main difference between the alternating current and DC current. Alternating current means where direction of current changes continuously or periodically. In a depth we can say the direction of movement of electron changes periodically. That is why the direction of current changes periodically. And when we come to the direct current, the current always flows in one direction. There will be no coming back. There will be no alternating in the directions of flow of current. So that is called as a direct current. Then how to represent, that is and one more thing we have to see, what is the advantage of this AC over the DC? Because you see, when we look around us, when we see our daily life, we use many things, many machines, or we use many equipments. We will use fans, we will use a television. I have given an example already. All these equipments and the machines works with the help of AC, which will use a AC to work. Then why don't they use DC? Then what is the advantages of using this AC over DC? That is, we should know here. See, I already told you the energy DC cannot be transferred to a very long distance. If it is transferred, there is a lot of energy loss. So, to avoid this energy loss, we should send a very high amount of energy. Again, it would be a waste. So, this is the one disadvantages of DC. And if you take the AC, if you take the DC, it cannot be converted. It cannot be converted into low or high of that particular of that energy. You cannot produce a very high energy. You cannot produce a very less energy. But it is possible with the alternating current. So you can energize. You can get high values of alternating current, or you can get a very low values of alternating current with the help of transformers. I think you have heard of this. You heard this word transformers. So let's study about this in this chapter itself, but later. So these are some advantages of this DC over AC. That is why we are always use AC. So this is some introduction part for the alternating current. Then there are some representations for DC and DC. See, we can say we will use some terms in this chapter that is called as the AC currents, and another one is AC voltage. And we also use DC current, and we also use DC voltage. These are the terms we will use in this chapter. DC current, it is which represents a current, but it is an alternating one. And this is a AC voltage, which is a potential difference in the case of alternating. And DC current means it's a direct current. DC voltage means it is a direct voltage. Voltage means it is a potential DC current. You already know about the current and voltage. And how to represent a AC source? We should know some, we will learn some terms, and we should know some of the things when we come to the alternating current, that is an AC source. Also we should know DC source. DC source means the example we can give it for is a battery. Battery is an example for DC source. DC source means which gives a DC form of energy. AC source means equipment, a device which gives a AC form of energy. That is called as a AC source. Then how to represent DC and AC sources? Let it be like this. AC source. There is a symbolic representation for this AC source. It will be like this. See, this is the representation of AC source. And DC source can be represented in this way. See, you have seen many times. This is the representation form of DC source. So you will use these notations while drawing the circuits, because you already know it. If we say resistor, you cannot write resistor in any circuit. You will draw the symbols in the similar way. While a AC source is connected to any kind of a circuit, we will symbolize that like this. This is symbol. And for a DC source, we will write this symbol, which indicates that it is a DC source and that is a AC source. So these are some representations, some notations which we use for AC and DC. This is a very basic knowledge that we must know while before entering into this chapter. And I told you two concepts. One is the AC current, another one is AC voltage. Then how to represent this AC current, AC voltage, as well as DC current and DC voltage? We will try to represent the values of currents. For example, if you pass a current in this circuit, if I draw a circuit like this is a resistor and current will flow like this. Let's say a variable current is flowing through this. Variable current means current is changing with respect to time. So then you can show the variation of current with respect to time graphically. So that is one way of representation of this current. In the similar way, we can represent the variation of this current and the voltage, AC current and AC voltage, as well as the DC current and DC voltage with the help of graph. So this is what I am telling you is, it is a graphical representation of the DC current and DC voltage, AC current and AC voltage. Let's see that. Graphical representation of AC signal. The AC can be represented graphically with the waves called sine waves. We already saw the sine waves in the first year. That means when you are studying about simple harmonic motion, same sine waves are used to represent the variation of current and voltage in the AC. So this is the graphical representation of AC. Along y-axis, which value you can take then? Either you can take I or you can take V also, because in AC two terms will use, that is AC current and AC voltage. That is why along this axis you can take I or V. Along this x-axis you can take time or angle also. Theta. Theta is also equal to omega t you can write. Okay? Angle can also you can say. And for the direct current then, what is the representation for a DC? You can also represent DC graphically. Here also you have to take the values of V and I along the y-axis. Here you can take the time here, but it is not possible to take the angle here. Why? Because it is a motion is it is an alternating one. It is a direct one. So see, this is the representation of direct current. See here. If you take the value of I along the y-axis, I is a constant everywhere. Okay, it is a constant everywhere. So this is the representation of DC. So this is the representation of AC, and I told you that in AC the direction of current changes periodically. With the time, with respect to time, it will change its direction. So let me tell you some more about this, some more things about this, because without this you cannot understand this chapter. I told you that along the x-axis we can take time or we can take angle. See here. Then how to take the time? It is very simple. There are the lines, and we can put the values to those lines like 1 second, 2 second, 3 second, 4 second, that depends. Then how to take this angle? Yeah. See here. See, this is a 0, angle is 0, and this graph is reaching to its maximum value there. This is a maximum, you see. If you take the y and x axis values, see, this is an x axis, and I am taking one point here and extending to x and y axis. This is y axis and x axis, so that I can get the values of this point on x and y. I can write the x and y value, right? Then which is and if you clearly observe here, this value of y is a maximum for this. There is no other value which is maximum than this. So it is the peak value of this curve. I am repeating, it is a peak value. Peak value means it is a maximum value. So it is a maximum value here, right? And once a graph reaches to this maximum peak point, the angle covered by this curve will be pi by 2. Pi by 2 means 90 degrees. Once the graph is reaching to 0. Okay, again the graph is moving from this angle 90 to next angle. Now it is coming here. Once it came here, angle covered by that electron, movement of electron is a pi. Or the angle, once the graph is reached here, then the angle will be pi. Again, graph goes on increasing, but in the negative axis, see here, this is a positive one, this is a negative. In the negative axis, again it is increasing, again it will reach a maximum value here. See, this is a maximum value. Okay. Again, the angle from here, pi plus pi by 2. So this becomes 3 pi by 2. Again, if the graph reaches here, angle which is occupied by this is 2 pi, which will continue. If you take the next cycle, again you have to add pi by 2 here. Okay, pi by 2 plus 2 pi. This is angle you have to add. Again you will get waves there, and that angle goes on continue. Okay, so these are the knowledge. This is some introduction to take the angles. This graph. Okay. So let me represent in another way. We can represent this in another way. See here, this is the R angle of axis theta. Theta is equal to omega t. Omega t means, omega means angular velocity. Okay, and see here, for all the points, see here, 0 to this part of curve which lies in this first point, because whatever the variation in the angle 0 to 90 degree, which will come in the first quadrant. Okay, so for if you take the any value of v here, that should fall in the first quadrant. Because angle is 90 degrees. So here from 0 to 90, this is an angle. And all the points of current and voltage which should lie in second quadrant, because this angle from 90 to 180, 90 to 180, it should fall in second quadrant. And all the readings of current and voltage on this curve from here to here, that should fall in third quadrant. And all the values of this curve should fall in fourth quadrant. Okay, so this is the some basic knowledge that we should know. I hope this is enough. These basic things are enough for you, and whichever, if anything else is required, I can explain in between the explanation of concepts.